All right, good afternoon. Good to see so many of you hanging on till the bitter end of what I noticed was actually the longest GOTO Amsterdam ever. So this is the first time ever that GOTO Amsterdam was there for 3 days and you stuck till the bitter end. And unfortunately, the end will be a bit bitter because I'm going to talk about a lot of nonsense that I've witnessed in microservices. You might remember that once upon a time, maybe yesterday or last Monday, there was a specific architectural style that used to dominate our industry. And anyone who's seen previous talks of me know that I will take every opportunity to say how much I like this architectural style. But I used a different diagram, and a couple of weeks ago I came across this one, and I just loved the absurdity of, we've got a problem, well, let's add a box to the cylinder, and maybe a second box just to be sure, and then we probably get better software out of that, right? So this is a typical representation of the layered architecture. And we don't want to put all the logic in one box, because that's not good. We need to separate concerns, so we add another box. So now we can split concerns. But most of this software, just like anything else, will just end up in what we would call a big ball of mud. And the big ball of mud, in most cases, is not made of mud, as you can see, with the architect still sitting on top of it. Now, the issue here is that the architect himself is not aware of the big pile of shit he's been creating. Excuse my French. And he's proud of it. This is his creation, and he will defend it, well, in this case, with his life, but he will defend it, and he doesn't see the problem. So given the giggles around here, I'm pretty sure you understand the problem of this type of software. So microservices to the rescue, right? We don't need to build a big monolithic ball of mud anymore. We can now build microservices. And why do we do that? What is the big promise? And it seems that we've lost connection with that big promise. What is the thing microservices should help us do? And it's pretty simple. They're all mainly about agility. So being able to make changes without changing the entire system. We can start swapping out small parts of a system. And they're about scalability. And I think the most powerful one is team scalability. Having concrete, isolated components that teams can work on individually, etc., etc. They're not so much about scalability in the sense of deploying multiple instances, that kind of stuff, because if you have a nice monolith, you can deploy multiple instances of those fine. Right? You can generally scale those out fine. The problem is most monoliths are not that well structured. But there's a balance, there's a price that we need to pay with microservices, and they come with additional complexity. In a lot of shapes and forms, there's a lot of technical complexity involved. That's why there's a whole array of Netflix OSS tools that we can use to deal with those. But using those tools doesn't have the complexity go away, it just gives you a means to deal with it. But another complex area is that very often it becomes very difficult to decide what is in one service and what's in another. And, well, you can imagine if you do microservices, you basically get something like this. And in practice, I see a lot of noun-driven design. And the principle of noun-driven design is very simple. It's a way we can design our microservices. It's a tool we can use, but please don't. It's a tool we can use, or that we do use, to decide what goes in what service. How do we discover services in our domain? And actually, this is what I've been taught in university, right? You want to find your objects? Go find the nouns. But now we do microservices, so if you find a noun, that's a service. So we get stuff like order service, customer service. Well, we all know customer service is a fake, right? Product service, inventory service, all that kind of stuff. And that's fantastic. So remember that the practices that we had in the old days would give us the mud, right? Now, what do you think happens when we increase the number of deployment units? Just get a big pile of shit. So is that in any way any better? Well, now you can swap out one pile of shit with another one, and then the system's different. Well, hooray, that probably won't work. And there's a lot of things you can do to discover whether you're working on that thing over there or on whatever's coming up in the top. If you notice that you are redeploying multiple services at once, congratulations, you're there. Right? If you have very strong dependencies on some other service doing something before you can do something, congratulations, you're down there again. It's very easy to get down there, right? As we'll see in a second. What we should instead focus on is to increase the modularity of the software that we're creating. And again, there's a lot of tools that help us with that modularity, but we need to use them right. But the promised land, well, starts over there, right? We've got this nice, structured, it's got happy colors, right? This is the last session of a 3-day conference. We need some happiness. So there's happy colors up there, and you can just see this is just great. We love this, right? It's simple, everybody understands. So there's some domain models in there. The code must be understandable, right? If you get an architectural diagram like that. And once we're up there and we're in this happy place with our our monolith, we've got this structured monolith. And now we can start thinking about increasing the number of deployment units. If only it were that simple. If only it was as easy as having a slide with 2 axes and just say, just go up and go right. Because unfortunately, on every office floor, there's a bunch of evil anti-modularity forces in play. And they come in lots of different shapes and forms. The most common one comes in suit and tie, telling you that the deadline shifted to a bit earlier. And as a result, we need to take shortcuts. And every shortcut you take takes you a step down there. Every little bit of technical debt that you add to your system brings you down there again. So that journey to the right is a pretty difficult one. And we need to teach ourselves to fight those forces. We need to be strong. We need to learn karate. No, actually what we need to learn is to wax a car. Right? So this is something in the 80s. They understood this in the 80s, right? You want to learn to grow, you wax a car. So this is the... who does not know this movie? Karate Kid. It's original. It's a must-see if you can still find a runnable copy out there. It's a movie from the 80s, and it's legendary. So this is the scene where Mr. Miyagi, on the right, he's teaching this American kid karate. Right? Well, that's a weird thing to do, right? How can an English or an American kid learn karate in the first place? But it's not, so he just wants to fight, right? That's what karate is about. But he's like, no, self-control first. Wax on, wax off. Right? It's all about discipline. If you can't wax the car, forget about karate. If you can't build a monolith, forget about microservices. In other words, there's a journey towards microservices, right? It's not you don't go from an idea, and this is one of my favorite icons, it means business model. An idea of some mechanism that makes you money, right? And, well, we want to achieve that with microservices, because that was what we promised ourselves in the previous project. We said the next project is going to be microservices. But the road there is a dangerous one. Animals die on that road. Or whatever it was. And it's easy to get distracted, right? So instead of getting to the promised land, we get into some place where it smells. So the road instead should be, it's a bit longer, but still, build that monolith, and then slowly evolve our way into microservices. Just step by step. Start carving pieces out of your monolith. When you find out that there's a necessity, and that necessity is never functional. It's never about functionality. It's always about non-functionals, right? It might be that the component, the blue one that was extracted out, has a memory, an insane memory consumption, and you don't want to mix that with the rest because it starts to claim everything it's got. Maybe it's a component that falls over quite often. You just want to want to have a bulkhead in between, etc. And then we start carving more pieces out, and maybe one day we'll do serverless. Like who? Amen. And what we need for that, the most important ingredient, I believe, that we need to make this a somewhat doable journey, that not for every step we need to go and ask those guys with the suits, remember, and the ties. We don't need to ask them for budget every time. So we need to be able to, without too much hassle, carve these components out. And location transparency is the means to do that. Make sure that these components are not aware about their respective locations. In the communication that they have, make sure they don't assume that they're in the same VM or in the same data center or on the same planet whatsoever. One day that will be a problem, right? Cross-planetary synchronization. So we've got events to the rescue, right? Events are a beautiful way to give us that location transparency. You just throw an event here, and you can catch it anywhere. No problem. So let's say that a service A has some interaction. And to be honest, I don't care what. And let's say service C needs to know about interaction. Well, a very common way is to say, well, A will just call C. Right? I've got a request, and now you do something. And that's great. The problem is when there's service B and D as well, we've got multiple interactions. Now, service A is currently aware of the existence of B, C, and D. What happens when E comes around, and F, and G, and whatever? This might make sense, but in many situations it doesn't. So what we can do instead is raise an event. And now service A can just raise an event, and service B, C, and D can watch that event and read it. There's no magic here, right? But there is a fundamental thing that is very important that we've done here. We've inverted the dependency. So instead of service A depending on B or knowing of B, C, and D, we've now got services B, C, and D basically watching service A. And even better than that, it's an indirect watching service A. They're just watching the events come out. And that's a very nice thing. So let's event all the things. Right? We've got a solution to a problem. So now all the problems become problems that we need to solve with that solution. We've got Maslow's hammer. Who does not know what Maslow's hammer is? Have you ever heard of, if all you have is a hammer, everything looks like a nail? That's that hammer. Maybe you've heard of a Birmingham screwdriver. Sounds like a cocktail? It's not, it's the same thing. You fix anything with a screwdriver. So both of them are not terms I like very much. Fortunately, if you look on Wikipedia, you'll also find this one. And I love this one because this sounds like something you can talk about with your psychologist. I've got Maslow syndrome. It's like, oh, so do I. It's horrible, isn't it? Yeah. Because it is a problem that we have. We become that little beetle on the ball of dung, right? So events, but they're not a bad thing, but let's not use them anywhere. And there's different shapes and forms of events. There's different ways we can use events, and there's different patterns that we can use with events. And one of them is event notification. Now, event notification is where events are used just to tell you that something happened. Just a little poke. That's it. There's not much information in those events. They might carry something like customer A, details changed. Like, oh, customer A, what's that? And then that service would go to fetch some customer data because it might have changed. That's all. A somewhat more involved form of events is the event carried state transfer. So there's a state change has happened somewhere, and an event is emitted to describe that state change in as much detail as is necessary for that state change to make sense. Right? So the event contains all the data necessary to explain exactly what happened. And we can take that a step further as well, and there's the concept of event sourcing that I'll also be briefly talking about. Event sourcing is where everything becomes an event carried state transfer. So let's have a look at what happens when you apply this in a dogmatic fashion. And this is what I've unfortunately seen in some event-driven microservices. And again, I'm not saying this is a bad pattern, right? It may be useful, but it's just a pattern, just like any pattern that you would use in specific situations. So let's say we have an order service, and there's another service that needs to know about the items that have been ordered. I don't care too much why, it's other department. I don't care what they do. So each service will have its own database or store to store its state. And for the replication, we use events. And these events carry all the information we need to basically define what happened. So there's order created, there's item added, it will tell you which item was added. Maybe there's also item removed, which will tell you which item was removed, and then we have order confirmed, etc. Now the service on the right is only interested in items that have been ordered, not items that have been added to an order. So there's a bit of logic that the service on the right, other right, needs to replicate. It needs to understand that an item is only ordered when it was added, then not removed, and then confirmed. So there's a bit of mathematics going on there, and not the most complex one. It would fit perfectly in a 101 class, but still, there's this duplication of logic, and that's annoying, because now if the rules slightly change, well, they have to change everywhere. And things got worse. I've once seen an example where someone proudly presented their event-driven architecture, and I was like, well, this is the most entangled choreography that I've ever seen. And it's the order service that says order created. Well, it makes sense so far, right? When order is created, that's pretty much a fact. And then the shipping service picks up that order and says, well, I confirmed the inventory. And now, okay, well, that could make sense, I guess. But now the order service needs to know about that inventory confirmed, and then says, I'm ready for payment. And then say, okay, order's paid. Oh, great. And now the order service knows when the order paid, then what do we need? Oh, yeah, we're ready for shipping. And just the style of communication is weird. When I see this, it feels like, I imagine things. I just imagine myself sitting on the couch at home going, oh man, I'm thirsty, and just waiting for somebody to bring me a drink. That's antisocial, I guess. And that's what's happening here. Oh, I'm so ready for shipping. And it feels weird. Why doesn't the order service just say, hey, shipping, go ship this? If it knows, it knows about shipping. Remember, the events inverted the dependency. But we've got two-way dependencies, and now how do we solve that? By inverting both. Oh, I can hear you're good at math. I'm happy with that. So what's wrong is because events have become the hammer. And there's not only events, there's also commands and queries, right? There's different reasons why components would want to communicate. And we've identified essentially 3 reasons why, in general. One is events, and they are just a way to explain something happened, right? It's what I've been talking about for quite a while already. And there's the commands, and commands are the intent to change something. It's just going to somebody and say, do something. Right? And the queries are messages you would send if you have a need for information. I want to know about something. And I know some other service or other component, for that matter, has the answer, but I just don't have it myself. And it's very important to realize that an event and a message is not the same thing. Not all messages are events. Now, how you do this in actual implementation, that's really up to you. Of course, we have an opinion, and if you want to hear about it, I'll gladly talk to you about it. So if we take that event-driven microservices approach and we apply the different types of messages, we can now say, well, there's a different way to implement this that will give us a much less coupled solution where the order confirmed is sort of a trigger, and then we do a query. And actually what we've been doing here is event notification. Except that there's some advantage of having this event-carried state transfer, because not all services need to communicate like this. Right? There's not one solution that fits all. But now we can choose, do we take an event as a notification that some important state happened, and now we want to get some information about the objects that are involved in that state. So now we've got events all over, and then there's a lot of misunderstanding around event sourcing. So some would argue, well, if you have this situation and you just store the events forever, then you've got event sourcing. Unfortunately, that's not really the case. You've got the easy half of event sourcing. Event sourcing is really about capturing the truth, the whole truth, and nothing but the truth. And events are a great way to do that because they tell you what happened, the truth. But unless you organize your code correctly, you cannot guarantee whether that is the whole truth. And you cannot guarantee it's nothing but, well, it's probably nothing but the truth, but you can't guarantee it's the whole truth. And that's the problem event sourcing tackles. And the whole idea of event sourcing is we don't store state anymore as state. We take, for example, the example here, we see that there's an order and there's a chair, and somebody bought a chair, but the status says return shipment received. So the chair was returned. Why? No clue. With event sourcing, you don't store the state and just don't overwrite the state every time it changes, but you store all the events that led you to that state instead. So we can see an order was created, and somebody added 2 chairs, not 1. And then he removed 1 chair, and then confirmed the order. And then it was shipped, and because it was canceled after it was shipped, we have to wait for the return shipment to be received. If it was canceled before it was shipped, it didn't have to be shipped, and we would have probably another state. Now, if we want to get the state, because in the end at runtime we want to work with state instead, so to get the state, we just replay all the events on, let's say, an empty order. We just replay everything and recalculate the current state. And event sourcing has some benefits. So if you have this order service emitting events, then you can do some pretty smart analytics, right? Maybe there's a pattern in this way people are ordering products that can tell you, well, you better hold this shipment off for a few extra hours, because we see that people that add 2, then remove 1, they might not be interested in the chair after all, but they thought, well, let's order because otherwise it won't be here in time. But that is not event sourcing. Right? This is just event handling. We can throw away the database on the right and reconstruct that, and some would argue, yeah, that's event sourcing, right? That is what event sourcing is, and there's a truth to that, because the big test on whether you're event sourcing or not is throw away everything except your event store. If you only have your events, can you reproduce exactly the state of the application? And the answer in this case is no, because the thing on the left is gone. So what we need to do is make sure that the order service itself uses the events it published for its own state in a consistent way. And that's where really the challenge is. So instead of having state, it will only have the history as its source of information. It's a very powerful concept, and it has some clear benefits. Some of them are business benefits, and some of them are really obvious and very strong, like auditing. If you have auditing requirements, then event sourcing makes that, and I'm quoting a customer, a breeze. You've got everything. So whatever your auditor asks of you, you can generate that out of those events, if they're not in the events themselves. But there's also a bit less strong requirements like transparency. Some businesses nowadays want to be more transparent about the data they have, mostly internally, so that they can use it, for example, for data mining, analytics, etc. There's a lot of value in that information, right? And there's a bunch of technical reasons as well. I've made those a bit smaller because they should never drive the actual solution. But there's a few nice technical reasons, and one of them is, for example, easily capture intent. It's much easier to understand what an application is doing when you've got events and commands going on, because they describe in a functional way what an application does, or has done, even. But there's some challenges as well. For example, you have to deal with increasing storage size, right? Adding appending events to a store and never deleting them, because it's the only thing you have. But nowadays, storage size, is that really an issue? You click, 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 and you've got a few terabyte extra. And there's a lot of solutions to help us manage. Right? There's actual event stores out there. There's products that can help you deal with that. So that's not a problem. It's complex to implement. If you remember your first programming day, everything was complex. Getting hello world on a screen, well, especially in Java, was really complex. Fortunately, there were other languages that were really one-liners, but we've learned to deal with that. We just need to keep on learning, and it's easy to say that here because that's exactly why you're here. And the other one is event thinking, and I think that is the only remaining real challenge, is to get the event thinking back. And there were a couple of sessions throughout the conference that gave you tools to do that. But it's a much more natural way to think about the behavior of an application. Just don't forget about the state. Think about behavior first. And if you analyze behavior of an application, you identify the events right away. So let's event source all the things. Well, I think you got it by now. Just don't. Right? Another hammer again. So do you want to event source all the things? Probably not. I frequently get asked, when would you not use event sourcing? Or when would you not use CQRS and things like that? And to be honest, I will not answer that question. So if you're using the app right now to ask questions, you won't get a full answer to that question. But you might as well give it a try. So let's see what an event store looks like in context. So we have an application, and it will send new events to this event store, and it will read past events to make new decisions. Right? And this mechanism works really well if you're processing changes. So if you're executing commands, you have this single entity, you want to quickly reconstruct that, that's fine. But if you suddenly have this query, you say, well, give me all the orders that are above 100 euros. Ooh, now you have to read the entire store, billions and billions of events before you know the answers. It doesn't really quite work well for those generic queries. And that's why we very often see it in combination with CQRS. So CQRS is a pattern, an architectural pattern, where you split the responsibility of an application into two parts. One part is responsible for handling these commands, and that works well with the event store directly. But since queries don't work very well with an event store, they want a different representation of the truth. Right? You don't want to go through the history book every time and again just to find out what country Amsterdam is in. You just want to know. You want to have some other model to look that up. Right? So we can project all the events into different models that are optimized for that type of question. Right? And there's a lot of benefits. We can handle non-functionals a lot better in this way. We can choose different approaches for the top one as opposed to the bottom one. Yes or no? So that's all nice, and that's all really nice theory and everything, but let's see how this works out when we don't really have the 6 services thing anymore. And notice that they're not big balls or little balls of mud anymore. They're kind of red boxes. But what if we've got a few more? Yeah, it's a lot, isn't it? What happens when we apply all these concepts at scale? And we need to realize that every time we have some form of communication, there's a contract. There's a marriage between the two components. And the disadvantage of events is that you have a marriage with lots of unknown other components. Now imagine, I'm pretty sure at home your partner, if you have one, will set some restrictions on how you can behave at home, right? And imagine that that's not one partner that you can identify and know, but it's unknown. People have expectations of you, but you don't know which ones. It's pretty annoying. Fortunately, again, there's technology to help us. There's consumer-driven contracts, right? So we can make them explicit. I expect of you to behave like this. Now run this in your CI/CD pipeline, and if it says okay, then you can drink from the milk carton straight out of the fridge. If not, then don't. Now, you want to restrict the scope of that contract, probably. Because if you just publish everything to everyone, like we're doing here, then the service on top that is publishing an event now has a contract with, and I was lazy, so I only added 4 services, but just imagine many, with all these services down there. And they all come with their consumer-driven contract tests, and they all overlap, and they're really annoying, and we have to manage all that. And then there's the concept of bounded context. If you want to take a picture, do it now, because yep, gone. Oh, no, yes, no, too fast, sorry. Because I don't want you to read all the slides. And ideally, conceptually, the bounded context is basically the area where certain words have a certain meaning. So for services that are within the same bounded context, they understand each other in great detail. So all these detailed order events, they make a lot of sense to other services that are in the order space. In the inventory space, they don't give a damn. They don't care about all those details. They want the big things that happen, like the order placed. That's the important stuff. So we want to be more careful about what events we emit, and especially when you use event sourcing. Because in the case of event sourcing, every little detail becomes an event. And every little detail that you accidentally publish to someone else is a marriage with the party and all that. So what we should do is basically assign all these services to bounded contexts. Now they're starting to look more happier, don't you think? It's more of a Thursday afternoon. Feels a bit like Friday. So we want to assign these services, and now we can see that there's 2 services in the same context. But we're still publishing everything to the same, there's no physical separation. So we need to make sure that those bars are also separated. Right? Because we don't want to have the same language on the 2 contexts. There's some transformation probably that we want to do. And the service on the right is fine. It's fine if that reads from the stream of detailed messages, because they understand that language, they understand what it means. They're probably even physically close to the teams that are developing the other service. But for the other one, you want some form of anti-corruption layer. You want to filter out the messages that are not important outside of your context, and those that are important, you probably want to transform them a bit. Decide whether you want to use this event-carried state transfer or event notification patterns. Again, choices. But there are different choices for the bar down there than they are for the one on top. So a slightly different representation would be like this, where you have these services communicate to each other. And within every bounded context, there's a lot of detailed communication. Not only events, but also commands and queries. Again, in the broader context of things, commands, events, and queries, but probably different ones. Because I promised you a way forward, I thought, well, I need to to give you some guidelines. Basically, I'm going to summarize some of the elements that I've said. And one of the very important things, and we've now seen projects that apply this from the beginning, to use commands and queries as explicitly as you use events. And doing that has helped these projects tremendously to reduce complexity, make them more evolvable. Maybe microservice evolvable should be a metric in code quality tools. Sharing is caring. If you share events with somebody else, you have to start caring about those events. You're stuck, right? If you're married, you have to care about each other. Right? And that requires responsibilities. Or that brings responsibilities. So be aware when coupling across bounded contexts, especially, because now your marriage is getting slightly out of control. It's way too broad. And if you if you want to go to microservices, it's a journey. Right? And whoever has been preaching microservices for a long time, I've seen it said so many times, like microservices are a journey. Right? You don't go head on in microservices. And what do? Guilty as charged. Microservices from day one. Let's make it a journey instead. Build yourself a monolith first. Try to evolve that. In other words, wax on, wax off. Get that discipline first before you start evolving to microservices. And I don't think this is a coincidence. Thank you.